Today we're going to take a look at composite shapes. A composite shape is just a shape that's composed, hence the name composite, of other smaller shapes, probably nicer shapes. Before we get started with that, we're going to talk about Pythagoras real quick, because we're going to have to use that whenever we get triangular shapes and we have unknown side lengths. So just quick reminders of Pythagoras, how it works. Okay, we have a right angle triangle, we know it's Pythagoras. We find the right angle, we know the side across from it is side C. That's the one that matters most. Here's my A and my B. Our formula, A squared plus B squared is C squared. So in this case, 23.1 squared plus 13.2 squared equals C squared. And we get out our calculators. Let's do our exponents first, BEDMAS rules. 533.61 plus 174.24 equals C squared. Add them together, all these decimals here, we get 707.85 for C squared. We don't want C squared, we want C. So we're going to have to square root. And if we typed in our calculator, I got 26.6 meters for C. If we try the other type, same idea. Find a right angle, locate side C. Here's my A and my B. Okay, same formula, 7 squared, A squared, plus B squared, oh, I don't know what that one is, equals C squared. So this is the out of order one, so we got to fix it. Let's take this number and drop it over here. So we'll get B squared is 25 squared. When we cross the equal sign, we do the opposite, so minus. Okay, calculator time, 625 minus 49. And that comes out to 576. But again, that's B squared. We want B, so we got to square root it. And B, I got to be 24 meters. Okay, we're going to use this idea of Pythagoras whenever we have a right angle, one of the little boxes, and we're missing a side length that we need. That often happens when we have triangular shapes, because we need a base and a height, and those always meet at the right angle. So today, what's our questions going to look like? Well, they're all going to look like this. Where we have a big, complicated looking shape, we're going to try and break into smaller, easier shapes. Ones that we know how to do and know how to use from our formula sheet. So when I look at this, I see some different shapes. I'm going to try and set the math up for us a little bit today so we can talk about what shapes do I see. Because if we think about it that way, it makes it a little bit easier. So I see shape number 1, it's a square, or just a fancy rectangle. I see shape number 2, also a rectangle, and shape number 3, a triangle. And I've got all of these shapes being added together, so I'm going to put plus signs between them. Step number 1, just write down what I see. Step number 2, what are the formulas we're going to need? Well, our rectangle is length times width, plus, I've got another rectangle, that's length times width, plus another triangle, well, that's base times height divided by 2. Right off our formula page. Just writing in what I'm going to need to use. Takes a second, but then it makes it a little bit easier to work with. Okay, let's fill these in with some numbers. So the kind of nice thing about these shapes is all these dashes. Remember that dashes mean they're the same size. So if this is my rectangle, there's my length and my width. 7.2 times 7.2 plus. The next rectangle has the exact same dashes, so there's more 7.2s plus. My triangle needs a base and a height. My base and my height have to meet at right angles. So here's the right angle, which makes the two sides that meet there the base and the height. Well, what's nice about those? We got those dashes again. So this last one, I got 7.2 times 7.2. But over here, don't forget, we have to divide by 2. Okay, so I'm just filling in the parts and pieces as they go. Time to do the math now. What is 7.2 times 7.2? We get 51.84 plus, doing it again, well, it's another 51.84 plus doing it again, but remembering to divide by 2 this time, you get 25.92. Okay, there's all my parts and pieces. If we add them all together at the end, final answer, we get 129.6. And because this is area meters squared, don't forget those units at the end. Okay, this is the idea we're going to try and do for all our composite shapes. Write down what you see, write down your formulas, fill the right numbers in, do a little bit of math, add them all together at the end. Okay, we're going to try it again, new shape. Oh, what do I see here? Let's look at part B first. So in part B, I see shape number 1. That's a half circle. Shape number 2, that's a rectangle. There's step 1, I see what I see. Step 2, my formulas. What is the formula for a circle? It's pi r squared, but it's a half a circle, so we've got to divide by 2. Plus a rectangle, we like rectangles. Length times width. Alright, let's fill some numbers in. So for my circle, I've got pi times my radius. Now, did they give us the radius? Yes. The center outwards, they told us it was 15. We divide by 2. Don't forget that part. Something people usually forget. Plus rectangle, length times width. Well, it's definitely 10 tall or wide. How long is it? How far is it from here all the way to here? Well, kind of a tricky idea here. If it says 15 on this piece, it must also be 15 on this piece because that's another radius. So all the way across, 15 and 15 makes 30. So we have 10 times 30. The order you put those in doesn't matter. 30 times 10, 10 times 30 means the same thing. All right, there's my numbers. Let's get our calculators out, do some math. And I get for this part here 706.86 for the circle. Got divided by 2 though. And over here I get 300. And if I divide that by 2, I get 353.43 plus my 300, which comes out to a total of 653.43. And what kind of units do we have up here? We had centimeters squared. Okay, there's our problem again. Finding shapes, identifying what we see, formulas, numbers, calculations. Okay, let's try the next one. What shapes do we see? Well, this time it isn't quite as obvious because they have not drawn in the little dashed lines for us. There's actually a few ways we can approach this one. I'm going to show you one right now. So if I look at this shape, I see that I have a big rectangle. Now, it really is a big rectangle with a trapezoid on the top, so that would be shape 1 and shape 2, or it could be a big rectangle on the bottom, a square on the top, a triangle on the top, maybe 3 shapes, or in this case, how I'm going to approach this one, I'm going to think of this as a big giant rectangle that has lost a triangle, because that's only 2 shapes, and they're pretty easy shapes to work with. My objective is to work with the least number of shapes I have to. I could have done the rectangle and the trapezoid, but trapezoids are tough to work with. They're messy. So I'm going to do this one as a rectangle, as shape number 1, and I'm going to take away shape number 2, the triangle. Now if I cut it off, that means I'm going to have to subtract the triangle. Okay, that's how the shapes I'm looking at. Formulas. Length times width for a rectangle, minus base times height divided by 2 for a triangle. Okay, some numbers. How big is the rectangle? Well, it's 8 by 6. That one's pretty nice to figure out. How big the triangle is, that might be requiring a little bit more thinking. And what do I mean by that? Well, I know it's 5 from here to the bottom. But what I really need is how big it is from here to the top. Now, cheating, looking over at the the left-hand side here, we said this arrow is 8. Right? Well, if that's 8, and this is 5, the difference between them tells you how big that piece must be. That's got to be a 3. Okay. Similarly, if I know the whole bottom is 6, and I've said the top is 2 on that left-hand side there, how much is left for this piece? Well, 6 minus 2 makes this 4. So there's my base and my height divided by 2. Now, as I said, you could have done this question in a totally different way and used a trapezoid or a square in a circle, a square in a triangle. It doesn't really make a difference. It can come to the exact same answer, but try and use the least number of shapes whenever you can. Okay, 8 times 6, math-wise, that's 48, minus 3 times 4 is 12, divided by 2 makes 6. Do this one all at one time because it's pretty nice numbers. And we end up with 42, and we had feet squared. Okay. That's our answer for that one. Now, just to show you, we could have done this a different way. If you didn't like this idea, here's option number 2. I'm not going to ask you to do 2 of them. Just pick one, pick whichever one makes the most sense. Okay. Option number 2 was I could have done this as the least number of shapes possible. Shape 1, my rectangle. Shape 2, my trapezoid. So rectangle plus trapezoid. Okay, formulas are length times width plus a plus b times h divided by 2. Okay, rectangle is still the same rectangle. Well, it's not quite anymore because now it's only 6 by 5 plus. Okay, I got the letter h in there, which means I need to find the right angle and the two sides that meet it. Well, here's the right angle, and here's the other one actually. So how big are a and b? Well, a has got to be the top, and b has to be the bottom. So in our case, we got 2 plus the bottom. That's this thing right here, right? The 6. How far apart are those things? Well, that's where you have to think a little bit. To figure out how far apart they are, I need to know how big it is right here. I know the whole thing is 8, and I know this bit is 5. And if I find the difference between them, I get 3. So we still have to do that difference thing. So times it by 3 and divide it by 2. Okay, how do we do the math? Well, 6 times 5 is 30. On the right-hand side, we got to do bed math. So 2 plus 6 makes 8. Okay, we're going to get 30 still, plus 8 times 3 is 24. Divided by 2 makes 12. And surprise, surprise, we get 42 again. Okay. Again, as I said, you can pick any shapes you want to. Try and pick the least number of shapes, and probably the easiest number of shapes that you can actually work with. I liked the rectangle take away a triangle. It looked pretty nice to me. All right, last one. I want to figure out how large the shaded region is. So when I look at this, I have to think about what is the shaded region. It's the space between the two rectangles. How do I find a shaded region? Always, always, always take your outside shape. Move that over a little bit. Shaded. Take your outside shape and subtract minus the inside shape. If I take the whole thing and I cut out the middle part, what I'm left with is the part in between. If you took a pair of scissors to this piece right here, you'd be left with the part in between, right? So what shapes do we see? Well, the outside shape is a rectangle. What's the inside shape? It's also a rectangle. They're just different dimensions. What's our formulas? Length and width. And length and width. Only difference is we're using different dimensions, so be careful. Outside, it's 11 by 8. Inside, it's 9 by 6. And we're subtracting because we cut it out. Just like in the previous one, we cut off the triangle. And if things are removed, you're subtracting. If things are added on to each other, you're adding. And our math, 88 minus 54, comes out to 34. And our units were inches squared. Man, that's our first introduction to composite shapes. We're going to spend a little bit of time on this. We'll be doing some more of these tomorrow because these are hard. And it's hard to see a shape sometimes or figure out which formulas to put together. easy to mess with the math here and there, so we'll spend a little bit of time on this one. And try the sheet. See if you can figure it out. If you're stuck, come see me, and we'll practice some shapes.